My name is Andris, and today I'm going to talk to you about my ASI fellowship project with Isaac Physics. Isaac Physics is an online platform that was created and is managed by the University of Cambridge and funded by the Department of Education. Isaac Physics aims to improve STEM education throughout the entire country by giving students the free resources to master their scientific knowledge through interactive problem solving. Anybody, any one of you, can go to isaacphysics.org and sign up and choose a particular subject that you want to master. You'll be presented essentially with a variety of game boards where your chosen subject is broken down into separate topics. Each hexagon here links to a series of questions on that topic. So say, for instance, if we wanted to practice our trigonometry, we would take the bottom right-hand hexagon and we'd be linked to a set of questions which we can then proceed to answer. An additional feature of Isaac Physics is the ability for teachers to enroll their students. So a teacher can enroll their students and assign some sort of assignments that the pupils can then complete. The teacher can view the progress of each of their students and identify any areas where there might be some trouble in understanding the subject matter. Now, what makes Isaac Physics a really great place is that over the last 3 years, they have collected very rich Clickstream data on over 62,000 users. They have affiliations with over 2,600 schools, and they have collected over 8 million question attempts. And as such, during this project, we decided to use this rich data source to tackle a problem that is endemic to many different online platforms, and that's the problem of user retention. So here, for instance, we have the number of users that drop off the platform after every month from registration. And what becomes immediately apparent is that within the first month, around 30% of users tend to leave the platform. And the reason for this is not clear. Here, for instance, we have a student who attempts 20 questions in his first month and then continues using the platform. But then here we have another student who attempts 80 questions but then doesn't use the platform afterwards. So to tackle this complex problem, we asked ourselves 3 main questions. First, can we predict user drop-off after 1 month of activity? Second, if we can do this, can we identify the key features that lead to user drop-off? And lastly, if we can identify the features, what kind of intervention can we propose in order to prevent our users leaving in the first month? So starting with predicting user drop-off, we looked at 8,750 students who were registered in September 2016. We looked at the teachers that they are affiliated with, and the teachers can essentially set them assignments to complete. And then for each student, we looked at their Clickstream data. So we looked at the questions that they were attempting, we looked at the videos that they were watching, and we looked at the hints that they needed to answer the question correctly. In addition to this, we also looked at their teacher's Clickstream data. So how many groups did their teacher create? Or how many assignments did their teacher devise? And how many students do they have? And then using this data, we said, well, can we predict who will leave the platform and who will stay? And with our machine learning algorithm, we can obtain an 87% accuracy in deciding who will stay on the platform and who will leave. Our 2 other performance metrics, precision and recall, are also significantly better than if we tried to predict user retention randomly. So now that we have a way of predicting user drop-off, can we identify the key features that lead to it? And what we found was actually that the most important features are the ones that are linked to the teacher. So for instance, it's to do with the total assignments the teacher has set, the users that the teacher has added, and the amount of times the teacher viewed the student's progress. Conversely, the least important features were the amount of questions that students attempted outside of their homework, which seems to indicate that teachers only really stuck to the questions that the students only stuck to the questions that their teacher asked them. As such, teachers are the star of the show. They are the main drivers of user activity. And that leads nicely into our last part in terms of proposing some sort of intervention. What we have to do is essentially target the teachers to retain our users. But then the question arises, what kind of teachers do we look at? Well, if you were to look at the teacher Clickstream data in detail, you would identify 3 separate groups. You would have your active teachers up on top, your inactive teachers down below, and you'd have this region in the middle, as defined by our red circle, which shows a melange of active and inactive teachers. And this is the region where inactive teachers tend to share similar features to active teachers, and therefore are the ones that should be targeted as they are more readily will be willing to use the platform. And we can target these teachers with with events such as workshops that encourages them to use the platform. So in summary, what we did is we looked at predicting user drop-off. We identified the key features that lead to user drop-off, and we proposed an intervention that can help us to stop it from occurring too quickly, or too much. And so hopefully, with these initiatives, we'll be able to expand Isaac Physics to even more students and help them to achieve success in their studies. Thank you very much.